Hey, what's going on, guys? Let's do this problem right here. This question is asking to find the equilibrium constant. So whenever we have equation like this, and if they ask for equilibrium constant, we use this equation, that is delta G is equal to delta G reaction is equal to minus RT ln K, right? So this is the one we are going to use. So let's maybe write this one right here, because we have to find delta G, so we need this space. So let's find the delta G first, but let's keep this equation in the right side. So here we have this equation, that is delta G is equal to minus RT ln K. So here R is going to be gas constant, that is 8.314, and then we have the temperature, that is 300 Kelvin, but we have to find the delta G in order to calculate the K, right? So let's go ahead and find the delta G value. So the standard delta G change for each of these molecules, we have to know that. So here H2 in original state, so this is going to be 0, and then this is going to be minus 300, and this is going to have minus 33, and then water is minus 22.9, actually it's 229, right? So these are the value standard change in delta G. Now let's go ahead and calculate delta G reaction. Delta G reaction is equal to sigma products minus sigma reactants, right? Sigma products, in the product side we have H2S and 2H2O. So let's write this one right here. So it's going to be H2S plus 2H2O, and in the other side we have reactants, that is 3H2 plus SO2. So these are the things we have. Let's go ahead and plug the values. First we have H2S, that is negative 33, plus 2H2O, this is going to be 2 times negative 229, minus, then we have 3H2, that is 0, then we have plus, minus SO2, that is 300, right? 300, and let's simplify this one. This is going to be minus 33 minus 229 times 2 is going to be minus 458, right? So this is going to be minus 458, and this is going to be minus, that's going to be plus 300, and if you calculate this one, that's going to give you negative 191 kilojoule per mole. And now we have delta G. Now let's go ahead and find the K. Now if you notice, let's rearrange this equation first. Ln K is equal to delta G over negative RT, right? Now we have to get rid of this ln, and we know that if we get e power ln, both of them cancels, and this is going to be just K. So K is equal to e power, but if we take e power, we have to take both sides. So this, if we take K, this is going to be e power this value. So let's go ahead and find this. So this is going to be K is equal to e power delta G over negative RT, right? And here we have gas constant. The unit of gas constant is joules per mole Kelvin, but if you see that delta G we calculate in kilojoule. So in order to cancel this joule, we have to multiply this one by 1000. We have to convert this kilojoule into joule. So to convert kilojoule into joule, we multiply it by 1000, and this is going to become, so let's continue this one right here, maybe here, right? So this is going to be K is equal to e power delta G, right? Delta G is negative 190. Actually, the equation for this one is going to be negative. So let's bring this negative in front. Negative, let's write this negative in front. And if you notice, delta G is already negative, and this one is also this negative, and before this equation we have a negative. And if you plug this value for delta G, negative, negative, this is going to be positive. So here we are going to have positive 191,000 over R, that is 8.314, times the temperature, that is 300 Kelvin right here. So this is 300, and this is, if you calculate this one, this will give you e power 78.166, and that is equal to 8.85 times 10 to the power of 33, and that's going to be the K value, that's going to be the equilibrium constant. Now we can finally go ahead and write, therefore K value is equal to 8.85 times 10 to the power of 33, and that's going to be the final answer. I hope you guys find this video helpful. See you next time.